Okay, so today we're going to put on our explorer hats for a really special kind of expedition. We're heading out on a data safari right into the heart of the animal kingdom.
And our main quest, the big question we're trying to answer, is something you've probably wondered about before. Do bigger animals actually have bigger brains? I mean, is there a direct link? Or is it maybe a little more complicated than that?
All right, let's just dive right in. We're going to track down the answer, but not with binoculars, no. We're using data points and graphs. So get ready, because we're officially on the hunt for some patterns.
Okay, so first stop on our safari is all about getting prepared. You know, like any good explorer, we've got to take our observations, our data, and turn them into a map that we can actually read and, well, navigate.
And here they are, our field notes. Check this out. We've collected data on a whole bunch of different animals. We've got everything from a tiny 3-kilogram cat all the way up to a 529-kilogram giraffe. And for each one, we've noted its body weight in kilograms and its brain weight in grams. This table, this is our raw intelligence. This is our treasure map.
And this is our map. In the world of data, we call this a scatter plot. See along the bottom there? That's our horizontal axis. And that's where we'll track body weight. And then running up the side, the vertical axis, that's for brain weight. Right now, it's pretty much uncharted territory, just waiting for us to fill it in.
So you might be wondering, how do we get our notes onto this map? Well, it's actually pretty simple. We just take each animal one by one. For instance, let's grab a goat that weighs 28 kilograms. We find 28 on the bottom axis, right? Then we go straight up until we're level with its brain weight. That's 115 grams on the side axis. And bam, we drop a dot right there. And we just keep doing that for every single animal until our map is totally filled out.
Okay, our map is charted, and now for what I think is the really fun part of any safari. Looking for the creatures that kind of stand out from the crowd. You know, the ones that don't seem to be following the rest of the herd.
So take a good look at our finished map. Use those sharp explorer's eyes of yours. Do you see a data point that seems, I don't know, a little out of place? Maybe one that's wandered way away from the main group of animals?
If you spotted that one point way up at the top, you are absolutely right. And guess what? That's us, the human. See, while our body weight of 62 kilograms is pretty average in this group, our brain weight of 1,320 grams is just massive compared to other animals of a similar size. That huge brain is what powers pretty much everything we do, from our complex languages to our ability to build entire cities.
And you know what? In data science, we've got a specific name for a point like this. It's called an outlier. It's basically a data point that's a major exception to the general pattern. It's a true lone wolf in the data set.
But even with our human outlier off doing its own thing, you can still kind of see a path forming with the rest of the animals, can't you? So our next job as explorers is to figure out the general direction of that path.
In this path, it reveals a really clear trend. In data terms, we call this a positive association. All that means is that when one thing increases, the other thing tends to increase too. So, in our safari, as an animal's body weight gets bigger, its brain weight also tends to get bigger. They're all kind of moving up and to the right together on our map. Now, to make this hidden path even clearer, we can actually draw a single straight line right through the middle of the herd. Think of it like this. This line represents the average trail they're all following. In the world of statistics, this is called a line of best fit.
Okay, so we've found the path, we've marked it with a line, but what does this path actually tell us? I mean, a good explorer needs to be able to read the signs, right? So let's decode what this line really means for our animals.
You know, the most important thing about this line is how steep it is. Mathematicians call this its slope. And for our animal data, the slope of this line is approximately 1. Okay, a number. But what does that number actually mean? Well, a slope of 1 is so much more than just a number. It tells a story, and this is the perfect way to translate it. For the animals on our safari, a slope of 1 means that, on average, for every single 1 kilogram increase in body weight, we can pretty much expect about a 1 gram increase in brain weight. See, it's a rule of thumb for the animal kingdom.
All right, so we've learned how to track patterns out in the wild. Now, let's see if we can use these same explorer skills for a brand new investigation. And this time, it's about us.
So here's the question for our next little expedition. Is your arm span, you know, the distance from your left fingertip all the way to your right fingertip, is it the same as your height? It's this really old idea. You've probably seen that famous drawing by Leonardo da Vinci. But is it actually true for most people?
To figure this out, we could plot data just like we did with the animals, but for this one, we can draw a special reference line first. This line represents perfect balance, where your arm span is exactly equal to your height. We're going to call it the line of perfect balance, but in math, it's just the line y equals x.
So check this out. If a person's data point lands directly on this line, they're perfectly balanced. Their arm span equals their height. Simple enough. But if their point is above the line, it means their arm span is longer than their height. Think of professional swimmers, they often have this. And if it's below the line, well, their height is greater than their arm span. It's a really simple visual way to test our own proportions.
So let's just quickly recap our Data Explorer's guide. It's a super useful 5-step process. First, you collect your data. Second, you create a scatter plot to actually see it. Third, you spot any outliers, the ones that don't fit the pattern. Fourth, you describe the association. Is it positive, negative, or maybe nothing at all? And finally, if it makes sense, you fit a line to model that relationship. That's it.
You know, we started today with a pretty simple question about animals, but we ended up with this really powerful toolkit for seeing the world in a whole new way. And that leaves us with one final really important question. Now that you're a data explorer, what hidden stories, what secret patterns are you going to uncover in the world all around you?